Assalamu alaikum. Hello everyone. I am Mustafa and welcome back again to my channel. It's great to see you here on this channel. Today's tutorial we're going to talk about uh, widely used test, alternative to t-test, which is Wilcoxon. As you know, parametric tests like ANOVA or repeated measures ANOVA or student have strong statistic power because they rely or depend on the on assumptions like distribution or normality and homogeneity of variance. These assumptions not always meet in the real time, so it's recommended to apply the alternative one, which is refers to Wilcoxon. So loading these four packages, the diverse ggpub statics and datarium. Datarium contains these two dataset, mice and mice2. There is a twist. For example, the Wilcoxon test have three main types. One sample Wilcoxon test alternative to one sample t-test, rank sum alternative rank sum Wilcoxon test alternative to unpaired uh, unpaired t-test, and paired t-test. So the alternative of paired t-test is signed rank Wilcoxon test using this following or this data set mice, which contains weight as dependent variable. The main or the goals of this test, Wilcoxon test, is to describe if there is a difference between, please pay attention, between median, not mean, between, for example, in this case, the median of weight and standard value or standard value or theoretical value. So there is one only assumption of the Wilcoxon test. The non-parametric Wilcoxon test is this results or the data should be distributed approximately symmetrically around the median, not the mean. So we can check this assumption using this command ggplot2 to draw a box plot representing the distribution of weight, mice only mice, and AAS aesthetic graphical x none between the double quotation mark y equal to weight, and only put plus geom underscore box plot. Sorry, there is gplot mice weight geom box plot. Oh, sorry, my bad. ggplot, only ggplot. So the distribution of the weight assumes the assumption because there is no outliers or huge outliers, and also the distribution of the results of weight, which is corresponds to the dependent variable, is approximately around the median. The median, this line in black, refers to the median. So this distribution is around this median. So let's go to the next step, which is refers to calculating or computing the test of Wilcoxon using following this command mice percent more than mice percent more than percent Wilcox underscore test, put weight tilde 1 because we have only one group, and for example standard value or theoretical value, for example 28. There is an error. Sorry, 28. Very well. So this output indicates that the p-value is less than 0.05, which indicates that there is a significant difference between the median, not the mean, the median of weight and this value or standard value, which equal to 28. We can check the effect size using this command, uppercase mice percent more than percent. In this case, we shouldn't or we needn't write Cohen's d in the case of parametric test. In this case, we can write Wilcox effect size or f size weight tilde 1 comma equal to 28. 28. So the effect size is large. R is equal to 0.88, closely to 0.9. So there is a large effect or difference between the median of weight and 28. We should copy this comment here and paste here. So if we want to draw or to show the results of Wilcoxon test on this figure, we should only add this comment plus labs. Only we should, for example, write the name of, for example, test equal to. So test 1 refers to the results of Wilcoxon for comparing between medians of weight and 28. So test 1 in this case, sorry, test 1. Very well. Test 1 refers to, instead to write all this comment, we can, for example, take this only this structure, for example, test 1. So refers to the results of the comparing test between medians, the median of weight and this value. So we can add this value of the results or the output of the test in the figure with following this comment plus labs and subtitle get underscore test label and write test 1 comma detailed equal true. In this case, we have successfully added the output of the text, the results of Wilcoxon test in this plots or in this figure. Move on the next test, which refers to the alternative of paired t-test, which is rank sum t-test, rank sum Wilcoxon test. So using this data set, mice2 contains two groups, before and after. The assumption of this case is if there is a symmetrically distribution of the differences between before and after around what? Around the median, not the mean. So we should only first add or compute the differences between before and after using the function mutate, as this command shall mice2 equal to mice2 % more than % mutate differences, for example, or difference between equal to before minus after. So in this case, we have a results of difference between the before and after. So the next step is to check if this value of difference is around the median or not. So using this following ggplot mice2 comma is static graphical x is none, y is difference plus geom box plot like this. Sorry, ggplot, not ggplot, very well. So this is the results. I think that the distribution around the median is approximately symmetrical without any kind or any outliers. So we can assume that this assumption and move on to the next step, which is calculating or computing the rank sum or the sum rank Wilcoxon test for related groups. We should rewrite mice2 and create another data frame which refers to mice2 using the function of gather to create new two columns between double quotation marks. For example, k is group and the value refers to weight, for example, comma before comma also after. So in this case, we can put head my_stu. We have two new variable group as independent variable contains two groups, which is before and after. Head function is only used to show the first 6 rows, and the weight is the response variable, refers to the value of each groups or of each individuals for each groups. So in this case, we can compute the Wilcoxon test using this following this comment %, more than %, Wilcox test weight tilde group, and we should write paired equal to true. I think should add only paired true. Yes, this is the result, the correct comment. So the p-value indicates that there is a difference between the median of weight between before and after, because the p-value is less than 0.05. So we can conclude that there is a difference, and we can measure the effect size using this command my_stu % more than %, Wilcox effect size, weight tilde group also paired equal to true. The effect size is large. The results is my_stu, yes, very well, is 0.88. So in this case, we can conclude that there is a large effect. If we want to draw the results of Wilcoxon test, we should only copy this comment for avoid the redundancy plus labs. Only we should write this one, for example, test 2 equal to this command, which refers to the test of Wilcoxon. We can, for example, check it, test 2, so this is correctly, and pass to the second command, labs, subtitle, get test label, and write test 2 instead to test 1, the first case, and detailed equal to true, equal true. What? Oh, sorry. There is an error. Here we should put group, and the unset difference we need to put weight. For example, and color weight group. Very well. So in this case, this results of this box plot shows the distribution of the weight of after and the weight of before, and the results of Wilcoxon test shows there is a difference between the median of after and before, with with a large effect or effect size. So let's go to the third one, which is rank sum Wilcoxon test, also named as the Mann-Whitney test, or also Wilcoxon two-sample test. We should use the head gender weight. So gender weight have two variable group as independent variable, contains female and male. Weight is the value of each individuals, which weight refers to or corresponds to the dependent variable, and group independent variable. Exponential variable and weight is a response variable. So using this following, gender weight % more than %, and for example, Wilcox test weight tilde group. Sorry. So the difference is very large, huge difference. 1.45 multiplied by 10 raised to the power minus 11. And we want, for example, we check the effect size, gender using this comment, gender percent more than percent, Wilcox effect size, also put weight, tilde, group. Also the effect is very large, 0.85 between female and male. And if we want to draw the results of Wilcoxon test as a box plot, we should first of all name it as, for example, test 3 equal to, and check it here, test 3. So very well. Here we need only to put ggplot function gender weight instead mice, aesthetic graphical, x is group, y is weight, example color equal to group, and plus geom box plot, also plus labs subtitle get underscore test label. Here we write test 3 detailed to equal to true. Very well, I think. So this is all of the results of the Wilcoxon test, shows in only one figure with the distribution of male and female of weight. So this indicates that there is a difference between what? Mean or median? Between median, because we have a Wilcoxon test refers to non-parametric test. So if, for example, the difference or the value of the difference, the results is not, for example, systematically or symmetrically distributed around the median, and if we have many outliers, in this case we have an alternative of Wilcoxon test, which is sign test, as for example this comment sign underscore test, like this. So the sign test is we use it to as an alternative of Wilcoxon test in the case of where the assumption is not met, where the case that we have our data have many of outliers, or the distribution is not around the median. So finally, if you have any question or suggestions, feel free to leave them in the comments below. I will make sure to put all of this comment in the description or in the comments below. Thanks. Thank you for so much for your patience and for following along. Take care of yourself and see you in the next video. Bye.